Hi, fourth graders. Today we're going to be talking about decomposing fractions. So decompose actually means to break down. And you might have heard this term before in science when you're talking about different types of things that can break down. So in decomposing fractions, we're actually going to be breaking down fractions. And we're going to be breaking up big fractions into smaller fractions. And this goes really well when teaching adding and subtracting fractions because it's very similar. It's almost the same thing. So when breaking down fractions, what you're doing is we're going to be doing them visually first. So I want you to take a look at this model right here. And in this model, the first thing you always need to do is figure out how many pieces are we looking at, how many is in the whole fraction, and that will help us find the denominator. So in this model here, we have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So we know that this whole model right here, this whole fraction would be 8 eighths because there are 8 pieces in all, and right now we're talking about the whole thing, 8 eighths. But when you're decomposing pieces, you're talking about breaking it up into littler pieces. So for example, say I end up coloring in one of these boxes green, and let's say 3 blue, and let's do 3 more as orange. So when you're looking at these, you are going to be making fractions. You are taking 8 eighths and you're breaking it down. So what we could say is that 1/8 plus, there are 1, 2, 3 eighths of it are blue, plus 1, 2, 3 eighths are orange, plus 1/8 is white. So let's see if that makes sense. Let's see if all of this completes this whole fraction. 1 plus 3, we know is 4, plus 3 more is 7, plus 1 is 8. So, and remember, we added all the numerators together, and then your denominator stays the same, 8, because we didn't gain any more pieces to our fraction. It stayed the same with one whole. So that is one way we can decompose a fraction if we're talking about the whole thing. Pretend I was just leaving this space instead. Let's pretend like we're just talking about 7 eighths instead. So this time we're going to be talking about 7 eighths. And let's pretend that we don't need that white one. It's just going to stay there. Well, it would look similar. We would do 1/8 green, 1, 2, 3 eighths are blue, plus 3 eighths are orange, and then we don't have anything there. So let's see if that fraction makes sense. 1 plus 3 is 4, plus 3 more is 7 eighths. So in that case, we were just talking about the parts that are shaded, and shaded is 7 out of 8 tiles. In this case, we were pretending this was white, and we were talking about the whole thing. So visually, all you guys are doing is looking at different colors and different spots and making sure that they all add up to our fraction. We can do this also visually on a number line. So I taught you guys last year, and we've worked on a little bit this year through YouTube videos. When you are looking at a number line and you're working with fractions, what you're going to do is count the lines. So I'm just making up an amount of lines right now to represent this. So let's say I come up with this number line. The first thing you're always going to do is count the hops, because every time that you see one of these, it makes the denominator a little bit bigger. So let's count how many hops there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that there's 9 hops between 0 and 1. We are just counting the numbers from 0 to 1. So if it gets further on, that's okay, but from 0 to 1 is where we're counting the bunny hops. So here we counted that there are 9 bunny hops. So that means our denominator is 9. So if we wanted to break this up visually, let's say on here we are talking about, let's shade in this blue, and let's shade in this part green. All right, so we know that in the whole thing there are 9 bunny hops, because from 0 to 1 there were 9. Now, when we're talking about the fraction piece, we're just looking at the shaded part for now. So we know that each one of these represents a ninth because the distance from this one to this one is 1/9. The distance between this one to this one is 1/9, 1/9, 1/9, because every time we skip one, we'd add another one to the ninths. Because when we are actually representing it, we'd say this is 1 out of 9 bunny hops, 1/9. This is 2/9, 2 bunny hops, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, and then finally 1 whole is 9/9. So each one of these represents a ninth. So if we are just looking at the blue part here and we want to decompose this fraction right here, we could say, okay, we know that in total there are 9, right? But we're only looking right now to get to 6/9. Okay, well, let's decompose that. We are looking at 6/9. Now we know that the blue plus the green gets us to that number. So let's see here how many blues there are. There's 1/9, 2/9, 3/9, 4/9. So blues are 4/9. Now let's count how many green. 1/9, 2/9, plus 2/9 are green, and let's see if that makes our fraction true. We know 4 plus 2 is 6, and we know we keep the denominator the same. Now, this will get a lot more simple when you get to just numbers. You'll find it actually very easy because all you have to do is when you see, let's say we do 9/10, and we're trying to come up with a decomposition. We're trying to decompose it. All you have to do is leave your denominators the same. And you can break this up in as many ways as you want. You could do 1 plus 1 plus 1 plus 1, or 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. Or you could say 3/10 plus 3/10 plus 3/10 would equal 9/10. You could do 5/10 plus 4/10. You could do 7/10 plus 2/10. You can break this up in as many ways as you want, as long as the numerators equal the numerator we are talking about, and as long as the denominators stay the same. Really quickly, I wanted to go over with you one of the worksheets you'll be doing today. There is an example at the top, but I just wanted to bring your attention to these parts right here. So what you're doing is we're just working with 1 whole at this point. So 1 whole would be this whole fraction strip, all this combined. Now, in the first part, we're talking about this many right here. And I can see it's very dark, but these are divided this is divided into fourths. So this is 1/4, 1/4, and 1/4. So that's 1, 2, 3/4. And this right here is 1/4. So plus 1/4. So our number sentence here would be 3/4 in these pieces right here. And then 1/4 in this piece down here, plus 1/4, equals, and we know that it equals a whole, 4/4. So we'll do one more to see it in a different light. Here we see it's divided for us, and we see it's divided into tenths because all the denominators are 10. And we know we're talking about 1 whole, this whole thing. So in 1 whole, I know that there's going to be 10 tenths. Because when the numerator and the denominator are the same, that means it equals 1 whole. So let's just look at these right here. This thing is called a caret, and we're going to be looking at this caret to see how many are in here. So first we have 1, 2, 3, 4, 5. We have 5 tenths are in this section right here. And I can even color them in to help you guys visualize. Now, in our next caret, we have 1, 2, 3/10. So these ones are right here, 3/10. And last but not least, in this last caret, we have 1, 2, 2/10. 2 1/10 fractions. I'm going to shade that in. So our number sentence would be 5/10 plus 3/10 plus 2/10. Now let's double check our work. We want to make sure that the numerators all add up to 10 And we see that all the denominators are 10, so that can stay the same. So 5 plus 3 is 8, plus 2 more is 10. We have 1 whole. So just remember, when you're decomposing fractions, you are just breaking them down, breaking all the numbers down into smaller fractions so that they can equal the fraction you're talking about. Good luck today, guys. Have fun. See you later.